we go. Good morning, sixth grade. How are we? Good. All right. So today we have students that are coming from their homes and students in schools. So welcome everyone. Today it's Monday, September 21st of 2020. Today we're going to review the three things that we've been working on the last 2 weeks. We're going to review 6NS2, dividing whole numbers. We're going to review 6NS4, GCF, greatest common factor, least common multiple. And we're also going to review some integer questions because based on the information that's been given in the last 2 weeks, we need a little support. You will also be having a test on Thursday on that information. So today is a reinforcement to review. Some of you mentioned, oh, Ms. Cannell, I need help with GCF. Oh, Ms. Cannell, Mr. R, I need help with LCM. Oh, I need a little help on integers with the vocabulary. So let's get started. I'm going to present my screen now. And if I call your name, I'm just going to ask for you to read the question and to give what you think. So here we go. Let me just pull it up. All right. So we are in here. Hold on one second. Why this is not. I'm going to open up with Cami now. All right. You guys know Cami. Let me just write the last person. I think we have about 20 people today. All right. Authorizing for my Google Drive. Here we go. All right. So again, it's going to be more of you and less of me. Okay. So today there is a few things. I can fluently divide multi-digit numbers and apply them to real world situations. 6NS2. Finding the greatest common factor and least common multiple of 2 or more whole numbers. 6NS4. And then last but not least, we're going to deal with explaining how positive and negative integers are used to describe quantities that have opposite values or directions and how they relate to the real world. So let's see. Carlos, can you read question 1 for me on the screen?
Sea level is located at an elevation of 0 feet. Here are the elevations of some locations in Death Valley National Park. Determine whether each of these locations has an elevation above or below sea level.
All right, so look at the bottom. So Carlos, campground is negative 218 feet. Is that positive or below?
Below.
Okay, so we're gonna write, if we had this open, we would put campground, and we would write negative 218. Everyone with me? So then I'm gonna take this, and I'm gonna cross that off. Daniela, Park Hotel, does that go above sea level being positive, right? Or is it below sea level negative? What do you think?
It's below.
Huh?
It's below sea level.
Why? Why is it below sea level?
Because it's negative 190.
Good. So Park Hotel would be negative 190. Okay, so now we're going to go across that one off. All right, Leah, gas station, does that go above sea level or below sea level? 1,926 feet. What do you think?
Above.
Above. Why is it above?
Because if it's a whole number, then it's automatically a positive. Or if it doesn't have anything on it, neither positive or a negative, it's automatically a positive.
Okay, because when there's no positive sign, you have to know that it's a positive integer. Perfect. All right, range station. Who else is on here? Hey, Jackson. Ranger station is 10 feet. Jackson, is that above or below? What do you think? It's 10 feet. When there's no sign, it's a positive integer. Therefore, is it above or below?
Which one do you say? Which one do you think?
10 feet.
Above? Above? Correct.
What'd she say?
I think she said above.
Above, she's correct. Remember, when there's no sign, it's a positive integer. All right, let's go cross that one off. Oh no, what happened to my thing? Oh no, I have to do it again? Oh no, it kicked me out. Oh no. All right, let's move on.
Yeah, everything's good.
Here, oh, here it is. Phew, I thought I had to do it all over again. All right, 2 left. Gift shop. Leah, gift shop. 3,000 feet. Above or below?
Above.
Perfect.
Above.
Okay, gift shop. Gift shop. And then we have, let's cross that one off. And then we have visitor center. Tori, negative 196 feet. Is that positive or negative?
Negative.
Okay, so is that above or below sea level?
Below.
Good job. Visitor center. Any questions on what we did here? What we did is we put them in categories, correct? Remember, above is always a positive integer, and a positive integer has a plus sign or just a regular number, integer like 10. 10 is the same as plus 10. Just like 3,000 is the same as plus 3,000. Questions on that before I move on? We're all good? All right, I'm gonna erase that. I see some of you taking notes. Okay, let's move on to question 2. All right, Tatiana, can you please read question 2?
The temperature rose 3 degrees Fahrenheit in the afternoon and fell 3 degrees Fahrenheit in the evening. Use the number line to find the total change in temperature at the end of the day.
All right, so Tatiana, going back to what we did the other day, if you look here, rose. When something rises, is that a positive integer or a negative integer?
Positive.
Right, so we're just gonna write, the reason why I'm putting plus 3 on top is you'll see in a moment. Now, if something falls or fell, is that positive or negative?
Negative.
Negative. The reason why I asked you to do that, you'll see in a moment. All right, so let's check this out. If we rise at 3, right, we start at 0, which is the center of a number line. If something rises, are we going to the right of the number line, or where the pink is, or are we going to go to the left where the green is? What do you think?
Right.
Right, because it's a positive integer, yeah? Yes? So,
Yes.
all right, so here's what we're going to do. We're going to start at 0. We're going to go to the right 3 times. 1, 2, 3. We now stop at positive 3. That's for rising 3. Now it fell 3 degrees. So obviously you told me that if it falls, it's negative. So do I move to the green to the left or to the pink to the right?
The green to the left.
All right, so here we are at the blue. We're going to move now 3 to the left to the green. 1, 2, 3. What number do we stop at?
0.
0. Does everyone see why this is 0 degrees Fahrenheit? Does anyone have any questions? Everyone good? Give me a thumbs up. Let's check the screen. Isaiah, you with us? Let me make sure. Let me check the camera. Awesome. All right, Natalie, I see you. Guess who's next, Natalie? You, girlfriend. Give me a moment. Let me just clear this up so we could use it at another time and I don't have to forget. All right, Natalie. Problem 3. All you. What does it say? Natalie? I think you're muted. Natalie?
A school wants to separate 360 students into equal-sized homeroom classes. There are 12 classrooms in the school that can be used for a homeroom. How many students will there be in each homeroom?
All right, so Natalie, what am I going to annotate? What is the A column?
Huh?
What are the key numbers or words in the A column? What's an important number here?
360
360 what?
students.
Good. What else is important? You got this.
12 classrooms. 12 classrooms.
Perfect. Any other important words? I'm just going to change the font, make it a little smaller, make it to 24, so that way. Any other important words? There's one more that's not annotated here. Equal what? Equal.
Equal size.
Good. All right, Natalie, you're going to do the R part, and I'm going to call on someone else to do the other two. Natalie, what do you have to solve for? What is the question asking for?
How many students will be in each homeroom?
Right. How many students will be in each home room? All right, let's see who's next on here. Let's call on Emily. You're up.
Write how you will solve the problem.
What do you think? What operation?
Division,
And what are we going to be dividing? How do I set this up?
we're going to divide 360 by 12.
Good. 160. I'm just going to put the slash divided by 12. So we're dividing, the 360 represents the number. Actually, I'm going to write it like this. Total number of students. Yeah? Everyone follow that? Divided by 12, which represents, what is that? Number of classrooms, right? Number of homerooms, number of home rooms. To equal the number of students in each home room. Does that make sense, guys? What Emily just said? Okay. So Emily, when you divide for us, 360, guys, type in the chat. 360 divided by 12. Emily's going to give us the answer, though.
I got 30.
30 what?
There will be 30 students in each homeroom.
Excellent, Emily. So the answer would be there. Oops, let me put the colon, because you know me. There, because I don't want just answers. I want you to tell me what it is. There are 30 students in each homeroom. Is that equally spread out? Yes, right? Good, 30 students in each homeroom. It is, awesome. So again, this question, the reason why you had to divide is because of the word it says equally sized. You want to find an equal number. If you have a total amount divided by the number of classrooms, you want to know how many kids can fit in each homeroom or each class. So that is why you have to use division. Does anyone have any questions? All right, I'm going to erase it. And you can always go back to the recording because I'm going to post it on YouTube. You can always go back and watch it as a review. All right, number 4, Justin Bodo. Can you please read number 4 where it says Mr. Blau, please?
Yeah. Mr. Blau runs every third day and swims every fifth day. If Mr. Blau, that's how you say it?
Blau, you got it.
Blau runs and swims today, how many days will he run and swim again on the same day?
Okay, so Justin, give me the key numbers in this question, please. What's annotated or what's important?
Something that's important is the third, like the third day. Every
And
third
what does
day.
he do on the third day? Does
He
run or
runs.
swim? Good. So we're gonna write third day equal runs. Keep
Run.
going. Go ahead.
And then he swims every fifth day.
Okay, keep going. What else is important?
And he swims today.
Okay, so they want to know when will they be together again, right?
Yeah.
Awesome. Okay, what is the question asking? What are you going to figure out for me? What do I want you to solve?
Like they want to know if he'll run and swim again on the same day.
Great. When will Mr. Blau, right? Because we know who the he is. He has a name. When will Mr. Blau run and swim again on the same day? I'm going to make that a little bit bigger for you. That way you can see that. Oh, yeah, no, that's way too big. But, okay, that's too big. Let's make that to like 24. Yikes, that's still a little large, but you kind of get the idea here. All right. Now, Justin.
Yeah.
we want to know when are they going to be together again. So are we finding the greatest common factor or we're finding the least common multiple? Which do we circle? What do you think? Look at the hint.
Wait, can you restate what you said, please?
Sure. Are we going to be finding the greatest common factor
Yeah.
or we're going to find that least common multiple, the LCM? Look at the hint.
Yeah.
You know what that is?
Yeah, I do.
Do you know what these are?
Yeah.
So the greatest common factor is you're finding numbers that are in common,
Which one it is?
and the least common multiple, when you see the word every, you're going to use the LCM. You're going to skip count. So which makes sense here? Are we going to skip count or we're going to list the factors of 3 and 5? What makes sense?
Thanks, skip count.
So that's called the LCM. So we're going to write in the text box, we're going to find the LCM of 3 and what number?
5.
Good. You're going to do this whole problem because I like to see you here bright and early. All right, we're going to find the multiples. Remember, when you find the LCM, you're skip counting. You are finding the multiples, which is the products of a number. So you're skip counting by 3s. 3 times 1, 3 times 2, 3 times 3. So Justin, 3 times 1.
Sometimes with numbers.
3 times 1 is 3.
Good, 3 times 2.
So 15, right? So
3
every
times
15th
2 is
day,
6.
Mr. Blau would run and swim at the same time, which I wish that was true, but it's not.
Hey, is that Mr. Blau in here?
Oh, you could hear me?
Yeah, is that Mr. Blau?
Yeah, I'm in with a group of kids, seeing if they can follow along. I thought I was muted. My fault.
Oh, it's okay. It's okay.
When I walked in, my name was in the problem, so you know.
Hey, the more the merrier, right?
3 times 3 is 9.
Keep going.
3 times 4 is 12.
Good.
3 times 5 is 18.
3 times 5 is, what's
Oh, not 18. So,
15?
15.
And 3 times 6 is,
3 times 6 is 18.
okay, let's go now find the multiples of 5, Justin. You're doing well. We're going to keep this up. Skip count by 5s because you want to know when is he going to run and swim together and what day. So 5 times 1.
5.
Is everybody okay? You okay? Okay?
10.
Good.
15.
Good.
20.
All right. So now my question is, guys, when, oops, that's too big. When will Mr. Blau run and swim again?
Participate.
Which number is the same from 3 and 5? What do they share?
They share 15.
They share 15. That is the LCM. Are we done yet or we got to go one more step?
I think we gotta go one more step.
What does this 15 represent? Look at the question, the R column. Mr. Blau will run and swim again on what day?
On the 5th.
You got it?
Or Mr. Blau will run on the 5th.
Will run and swim together on what day? On the
5th.
15th day. So Mr. Blau is going to run and swim together on day 15. That's what that is. That's what that LCM shows. So remember, thank you, Justin, and thank you, Mr. Blau. Remember, when you guys find the least common multiple, you actually are skip counting. You're finding multiples. Remember, when you multiply, the numbers get larger. Okay, when you multiply, the numbers get larger. And that is what you're doing when it says the word here, every 3rd and every 5th day. That is why you have to use the least common multiple and not the greatest common factor. Thumbs up if that makes sense so far. Let's see, I'm checking the gallery. I see Tatiana. Okay, Natalia, I'm not sure what's going on here. All right, looks like everyone that I've seen so far, pretty much. Let me just ask a question. In Mr. Dennis's room, how we doing in there, guys? Thumbs up? Can we move on? All right, I'm going to call on somebody in Mr. Dennis's room to read the next question. Let me just erase this. All right, we have, is there a Brandon in there, Mr. Dennis?
Yes, Brandon's right here. Can you see him?
I can see him. Is the green shirt on?
Yes. Go ahead.
Brandon, are you able to see my screen and read this? Number 5? Yeah? Okay, go ahead. What do you got? The table below.
Below shows elevation from several natural features.
So what is, go ahead, natural feature. What does A say?
A says Mr. Everest. B,
All right. Mm-hmm.
Rainer.
Mm-hmm.
C, Grand Canyon. D, San Augustine Cave. E, Dead Sea. And the elevation 29,022.
So I'll help you out. 29,022 feet above, 14,410 feet below, sea level, 2,189 feet above, and 4,786 feet below. Before we tackle the question, I need to ask you this. If you're above sea level, are you positive or negative?
Positive.
Good.
Positive.
Good. If this is 0, you're above. It's in the positive. So what I'm going to do is I'm going to put a plus sign here so I remember. If you are below, is that negative or positive, Brandon, in your class? Somebody in your class, help you if you don't know. Call on a classmate.
Who?
Steven.
Steven, he called on you.
Below, is that positive or negative?
Negative.
Good. All right, another classmate. You call on a classmate. What does sea level mean? What number? If you're at sea level, you're at the center, which is what number? Every time you count, what number do you start with? You start with 1 or you start with 0?
0.
Good. All right, call in another classmate in there. The word above, is that positive or negative?
Say it louder.
It's positive.
And the word below is what kind of integer? Negative, right? All right,
Yeah.
so Brandon, let's continue on to the next part. Ladies and gentlemen, this is a 3-point question that was on the state exam. So it asks you to write the name of the natural feature. So we're going to copy Mount Everest. And then you have to put this math into, this wording into math. So it's going to look like this. We're going to write Mount Everest. Ooh, what's going on here? Let me make this a little bit smaller. Mount Everest. Now, Mount Everest, if you look at the chart, you all told me that it's positive. So Mount Everest, written as an integer, is plus 29,022 or 29,022. Oops, that's 33. Because an integer that's positive has either the plus sign or no plus sign. They mean the same thing. Does everyone understand that? Yes? All right, if I'm going too fast, just tell me. Letter B, Mount Rainer. You all told me that if it's below, it's what kind of integer? Somebody, Kayla?
Negative.
Negative, so I'm just gonna put minus, right? Or negative, 14,410. Letter C, Grand Canyon. I'm gonna write Grand Canyon on my paper. I'm gonna put a colon. It's sea level. So Justin, Sea level, what number is that? It's right there on the chart in blue. Camera on, Kayla. Sea level.
0.
Good. You write 0 there.
I thought I had my mic on.
Okay, next question. San Augustine Cave. Oops. Arlenis, San Augustine Cave, letter D. What kind of integer is that? It says above.
A positive integer, yeah.
How do we write the two ways to show a positive integer?
Plus 2,189 feet, or just 2,189.
Excellent. I want you guys to hear what she did. She gave me both ways. And the last but not least, Dead Sea, Carlos. It says below. Is that a positive or negative integer?
The screen is small, so I can't see it.
All right.
All right.
It says below.
Dead Sea is positive.
It is? The
It
word
is.
below? The word below is positive?
No, wait. It above. It's above.
When it's below, it's a negative integer, right? Because you're below 0. You're down deep. So it's negative, right? 4,786. Now, you can go back on mute, okay? Now, this is the trick part. You have to tell me how you know when something is a positive integer, when something is a negative integer, or 0. So I'm going to change the color and write in purple now.
I know.
So, who said I know?
Me, Justin.
Okay, Justin. So when you have a positive integer, what's the key word?
Positive means above.
Above what?
Above sea level.
Good. Okay, that's the first part. Let's do the next one. If you have a negative integer, what's the key word?
Below
Below
sea
what?
level.
Good. And the last one, when you see sea level, what kind of number is that?
0.
Good. Anyone have any questions on that? I know that was fast. I just want to recap, right? Anytime you see above an integer, and I'm going to show you something here. My drawings are not the best. I'm going to try my best here. I want to show you something. Here's a number line, vertical number line. This is 0. Oops. Okay, this is 0 right here. These numbers, right? 1, 2, 3. These are all positive. These are above. When you go under or below, we have -1, we have -2, we have -3, and so on and so forth, right? All these blue are negative, which are below sea level. Does that make sense? Does anyone have any questions before we move on? All right. Thumbs up if you're with me. I don't see Tori's thumbs up, so I'm not sure. All right. All right. Andrew, I think I'm going to call on you next. Let me just erase this. And you guys can always go back and watch this. This is serving as a review because your test on Thursday is going to be very similar to these questions on Google Form. So it should be an easy grade. All right, number 6. Andrew, I didn't hear from you yet. Can you please read this problem?
Kayla has 24 muffins, 18 breakfast bars, and 12 bottles of juice to be distributed evenly among the certain number of welcome baskets. She wants to package the maximum greatest number of welcome baskets that will contain the same number of combinations of muffins, breakfast bars, and bottles of juice. What is the greatest number of muffins, breakfast bars, and juice bottles that she can evenly distribute?
All right. So let's look at this, Andrew. Andrew, you're going to do the A and R column. Can you tell the class what to write, please? Because I don't know. I forgot. Can you help me out?
For annotation, 24 muffins,
Mm-hmm.
18 breakfast bars, and 12 bottles of juice.
Making me hungry now. Right?
I ate already, so I'm okay.
Any other important words?
It also says package the maximum greatest number.
So maximum means greatest.
So we're going to find the GCF.
Yeah, how do you know that? What's the key word there that gave you that idea?
Greatest.
Ah, perfect. So he says we are going to find the GCF because it tells you the word greatest number. You see that? Maximum. Does everyone see that? So technically, Andrew, what are you finding? The GCF of what?
The GCF of 24, 18, and 12.
So what is the GCF of 24, 12, and 18? And we want to know the word evenly distributed, right? Right?
Yeah.
Okay, can't forget that. Make that a little bit larger. All right, next one. Hazel, what are we finding here, Hazel? We're finding the GCF for LCM. We circled it in green.
GCF.
Of what numbers?
24, 12, and 18.
Good. All right, let's do that. All right, we're going to list the factors of 24. The 24 is going to show me the muffins. All right, so let's do the factors of 24. 1 times, Natalie, 1 times what?
1 times 24.
Good. 2 times.
12.
Good, keep going.
3 times 6. 8.
And 4 times what?
Um,
4 times 6. It's a little smaller. Perfect. All right, next. Let's go find 18 bars. 1 times what? 1 times what?
18.
And
2 times 9.
good. I'm going to put that up a little bit. All right, last one. We got
12.
12. Go ahead, 12 times. 1 times what?
12. 2 times 6.
And
3 times 4.
good. All right, my question to you, Natalie. What numbers do both 24, 18, and 12 all have in common? Give me a number, please. Do they have 1 in common? Do they share a 1?
Yes.
All right, so we're going to go circle that. 1. What other numbers do they have in common, Natalie? Do they share 2?
Yes.
Okay, Tati, you're going to take over. Tatiana, what other numbers do both 24, 12, and 18 have in common?
6.
They all have a 6? Yes, you're right. We forgot a factor here. I goofed up. Oh boy. 3 times 6. You're right. My mistake. You were right. I was like, wait, I didn't see it. They share a 6. Oops. Sorry about that. That's a little sloppy. 6 and 6. Any other common numbers shared? Tatiana? No. Azalea? Can you tell me the greatest common factor of 24, 18, and 12, please?
6.
Okay, but did we finish or we have to find the maximum number they can have? Did we finish or we have to go one more step?
We have to go one more step.
All right, so help me out. If the GCF is 6 and I want to have 24 muffins, how many packets do I need to get to 24? 6 times what is 24?
Times 4 is
Okay, so
24.
4, yep. 4 packs, I guess, or baskets of muffins, whatever you want to say. All right. If the GCF is 6 and I want to get to 18, 6 times what gives me 18?
6 times 3 gives you 18.
Good. So 3 packs or baskets, same thing. 3 packs of bars. And if the GCF is 6 and I want to get to 12. Oh, they also shared a 3 here. I didn't catch that until now. See? What number times 6 would give me 12?
2.
So 2 packs of juice, I guess, of bottled juice. Okay. Now, I want to recap. How do we get this 4? We know that the GCF was 6, so 6 times 4 equal 24. 6 times 3 equal 18. 6 times 2 equal 12. Now, each one is evenly distributed. As the question states, the maximum number of muffins, which are 6 packs or 4 packs of them, the maximum number of bars was 3, and the maximum or greatest number of juice were 2. Does anyone have any questions? Because this is where we get stuck. All right, we're almost done then. We've got 2 left, and these last 2 will be quick, I promise. This is what you're going to see on your quiz, or your test on Thursday. All right, point M represents 1/2, and point N represents 5/2. Which number line correctly shows point M and N? Let's call on Kayla. Kayla, the half, is that positive or negative? Kayla, 1/2, is that a positive or negative number?
Positive.
Good, so which answers are wrong? Is M on positive here? Is this M at a positive integer?
No.
No, so let's cross it off. We're going to eliminate what's wrong. So we're going to cross it off in blue. Is this M at a positive integer?
No.
Yes. Is this M at positive and letter C?
No.
No. Is this M at positive?
Yes.
Yes, but what number is it on?
2.
And what number are we supposed to have it at?
1/2.
1/2, which is 50. So this can't be right? So let's go over why this is the correct answer. Okay, I'm going to write some notes here to show you. Point M. 1/2. If you have $1, what's half of $1? If 50 cents. So 0.5 is the same as 0.50, and this has to be on the positive, right? Now let's look at point N. We have 5/2. Mariama, if you have $5 and you give me 2, how much do you have?
3.
5 divided by 2 is 3. If you have $5 and you divide it if you have $5 and you want to share it with 2 friends, how much money do you have? 5 divided by 2 is how much money? $2.50, right? $2.50. 250 times 250 is $5, right? I mean, 250 times 2 is $5, yeah? So
Yeah.
Wait a minute. This actually would be positive. I made a mistake. This isn't the correct answer here. I messed up. So let's look. Something is wrong here. Hold on a minute. So let's do this again. All right. We want to find a number line that shows m is positive at 0.5. So m is 0.5 here. And m is a 2 there. So this is 0.5. And we want to find where n is 5 over 2, which is 2.5 in the positive. I think this has a typo. This is actually supposed to say, now that I think about it, this is actually supposed to say negative. This is supposed to say negative, so that this wouldn't be positive now. That this would be actually my mistake here. This would actually be negative. Sorry, guys. Because I'm like looking, I'm like, nothing makes any sense here. My mistake. You couldn't see that. So we want negative 0.5, which would be on A. And we want positive 5 over 2, which would be choice A. My mistake on that, right? I'll go over that one again. So negative 1/2 is in between 0 and negative 1. This is 50. And we want positive 2.50, which is right here. So that is why A is correct. If they asked you for the opposite of negative 1/2, you would say it's positive 1/2, which would be choice B. If they asked you for the opposite of n, which is 5 over 2, which is 2.5, it would be here. So this is just saying m has to be negative 1/2, which is point m on A, and n, which is 5 over 2, is this point. Therefore, it's choice A. Let's move on to the next one. Sorry about that. Last problem of the day, and then we're done. And then you're free to go to your next class. All right, last one. Really quick. This is a number line, okay? Very simple. It tells you positive is above, negative is below. All right, how far above is the mountain? Look at the chart, the mountain. How far above is the mountain? Natalia, Natalie, Anaya, Natalie, Anaya, go ahead. The mountain. 2 what? 2 units above or below? Above, right? All right, now you're going to finish up this problem. Get the thinking cap on. You ready? You got this. How far below, which is negative, is the fish?
-1.
-1, we say 1 unit below. Okay, so you do know. Is the airplane, which is here, where my cursor is, above or below sea level?
Above sea level.
Good, above. Good job, guys. Above sea level. Which 2 objects are the same distance from 0? So let's go graph them. So let's go graph the mountain, which is here. This is the mountain. I'm going to color code it for you. Mountain in green. Next shape, the fish in pink, is here. Purple, the ship, -4. And this one, the airplane, which is +4.
I think fish one. Fish.
Which 2 objects are the same units from 0? So remember, if you think of 0 as the center of your number line, where I'm going to put the yellow mark, how far away is 0 from 4?
4 steps.
4.
How far is 0 from -4?
4 steps.
4.
4. So which 2 are both 4 places away? 1, 2, 3, 4, which is the ship. And 1, 2, 3, 4, which is the airplane, yeah?
Yeah.
So what we can say here is that opposites have the same distance from 0, right? So we're going to say the ship and airplane, are 4 units from 0 on either side of the number line. Does that make sense?
Yeah.
Yes?
Yeah.
Okay, you guys sure? Which 2 objects are opposites of each other? Somebody. We just kind of went over that answer just now. We just did it. What's the opposite of a positive 4?
Negative 4?
Negative 4, right? What's the opposite of a negative? A positive.
Positive 4.
So the
Yeah.
ship and the airplane are opposites. Last question. Name the 2 positive objects. What are the 2 positive objects?
Airplane and mountain.
Airplane, airplane and mountain, and oops, and which 2 are the negative objects?
Fish and sun can ship.
Yep, the fish, which is -1, and the sunken ship, which is -4. So fish and sunken ship. Does anyone have any questions on what we did? Is everyone feeling better now? More confident now on GCF? Thumbs up. LCM and integers, because this is what you're going to see tomorrow and Wednesday, and on your test on Thursday. You should always be able to get 100 if you came. And office hours, yeah? All right. Just remember that a positive is above and a negative is below. And if it's at sea level, it's at 0. Real quick, I want to hear back from Joelle. How was this lesson today for you on a scale of 1 to 10? 10 being top, 1 being I don't got it.
A 10.
10? What about you, Anaya? How was this lesson for you today? Well, I don't know what that means. Give me numbers. 10 being the best, 1 being I still don't get it, miss. Huh? 10? What about you, Daniela? How was this lesson for you? Then I'm going to let you go.
10.
10. Natalie? Natalie, how was this lesson for you?
10.
Tori? Leah? People wrote in the chat. Okay, 8. Leah said 8. Okay, we'll talk again tomorrow. Emily, how was this lesson for you?
10.
10, understandable. Okay. If you guys, Joelle, how was this lesson for you before I go? I don't want you guys to be late to your next class.
I said 10.
10. If you feel you need more support, you can email me. You can email Mr. R. We will be reviewing this again in office hours tomorrow. So please make sure you're in class on time, logged in on the camera. Any questions?